This is a demonstration of chromatography, and you'll notice that we're going to put two pieces of chromatography paper with each have two different dots of ink on them. The left dot is from the same marker on both of these, and the right dot is from a different marker. Notice that the dots are black, so it's black ink, but despite that, you will notice again, this is a separation technique, so the black ink is actually made up of different components, and we can see those different components and compare which components are there based on the distance they travel up the paper. So you'll notice that we've got a sign on the left here that says that's water. So the liquid, that's going to be our mobile phase. That is, well, you know what happens when you put a piece of paper into water. Sometimes the water kind of spreads up the paper, and so that's essentially what's going to be happening. On the right-hand side, we have the same setup on the right-hand side except with ethanol, and we're going to see what happens. So we'll play this. And so you notice the right here you can already see the mobile phase traveling up the paper. The paper is referred to as the stationary phase, and then the ink is the mixture that we're trying to separate. And you can see that the ink is starting to be drawn up the page. Water and ethanol have different polarities. So water is super duper polar, has the ability to hydrogen bond with itself and with other molecules that have the O to H, H to F, or H to N bonds. Ethanol does have some ability to hydrogen bond with this OH group at the end, but we also have some carbons and hydrogens which are like a non-polar end of the molecule. So again, because of that difference in structural makeup for our mobile phases, we're going to notice a difference in how the inks travel up the page. So I'm going to fast forward this a little bit and we can see what happens after some amount of time has passed. So you'll notice that the first ink, so right now the mobile phase is right about here. You can see the edge of the ink, and then the mobile phase in the ethanol is right here. That's how far up it's traveled so far. And you'll notice that the first ink here has some attraction to the mobile phase, and eventually it kind of stops going along with it. This ink on the right, though, has a lot of attraction to the mobile phase, but the different colors have different attractions. So notice that the yellow didn't go quite as far. Then we've got the, there's a reddish color, and then this like bluish blob is going to keep going. You'll notice when we look at the image on the right, the ethanol is definitely, with its less polarity, not able to bring the ink up as far. So you can notice the difference in the separation. So again, this is just an overview of what chromatography, paper chromatography would look like. But again, the different solvents, the different type of mobile phase will carry the different ink components different distances depending on the attraction to the mobile phase itself versus the attraction to the paper.